Greetings, my name is Parth, and today our team, myself, Tavish, and Manoj, are going to present to you an interesting problem that we worked on, a problem that has far reaching business impact. Now, any organization will have its vendor base, that is, other companies that it engages with to procure goods and services that it can use. As an organization grows larger and larger, the system becomes more and more complex, and there are a lot of inefficiencies in the system. Our client had a similar problem, and they wanted to approach it with an analytical mindset and wanted a reproducible solution. Now, a bit about our client. They have more than 200,000 vendors that they have engaged with in the past 5 years. They have more than 5 million transactions with these vendors and more than $10 billion spent. They have operations in more than 40 countries. You can imagine how complex the system would be and the number of inefficiencies in the system. Now, our client did not have any vendor management tool they were using, and vendors were basically only categorized on the amount basis the amount spent with them. When we further examined the data, we saw that the spends were highly imbalanced. Only 5% of the vendors accounted for 90% of the entire spends. Our approach to the problem was basically on a overall level to normalize the names and get external data, which we could use for clustering. We would then perform clustering based on the amount spent and a few exogenous variables. We faced a lot of complexities in the data and in our project, which was we had to make it dynamic so a user could specify the weights for clustering, and also we had to create an Excel dashboard, which was a bit challenging considering that the number of records exceeded the Excel's capacity. I'll hand over to Tavish, who will talk more about the data and the methodology.
Thanks, Parth. So the data sources that we had were the spend data, which was the client data, and it consisted of the amount that the client had been spending on different vendors to procure different services for their firm across 13 categories. The other data set that we had was the risk data set, which we had scraped ourselves from Yahoo Finance, which quantified the level of risk associated with each vendor. It consisted of ESG scores. Now, the first step in data pre-processing was we first did some variable data cleaning and missing value imputation on the spend data. After that, we had to perform name normalization to remove duplicacy in the spend database on the basis of the name of the vendors. Then we had to find a method with which we could unify the spend and risk data on the basis of vendor names and bring it into one database. The methodology that we followed here was now the spend data consisted of vendor names which were provided to us by the client, whereas the risk data consisted of vendor names which were standard web names as it had been scraped from Yahoo Finance. This posed a hurdle for us, and we had to follow text similarity algorithms here so that we could merge them and form a unified data set. Once this was done and our data set consisting of spend and risk was ready, we had to assign weights to spend and risk, which could be specified by the user. The other problem that we were facing was that we had to first find a way with which we could consolidate our vendor base to a restricted few, because performing a clustering on 200k vendors wouldn't have been fruitful. So through Pareto principle and recency in vendor activity, we were able to restrict and reduce our vendor base from 200,000 to 9,000. And we were accounting for 95% of the spend in this reduced vendor base. Now our objective function consisted of spend, the weight that is assigned to the spend, and 1 minus risk, and the weight which is assigned to risk. This is done because we want our top tier vendors to be high spend and low risk. Moving on from the objective function, now our data set is ready to be fed onto the clustering model, and which Manoj will take us through.
Thank you, Tavish. Now coming into model building, I first want to touch base on the graph that you can see on the screen, where on the x-axis we have the recency of the vendors along with the total weight that we'd want to apply on the spend metric in increments of 5. And on the left vertical axis we have the total vendor base reduction, and on the right vertical axis we have the total spend reduction. As you can see, the most optimal parameters, which is indicated by the flat black line, which says that applying a 90% weight on the spend, considering 40 months of recency, which means we consider all the vendors that were in business with our clients for the past 40 months, we see that we achieved about 90% reduction in vendor base with a trade-off of only about 13% reduction in spend. So using these optimal parameters, we based our further studies and further recommendations as well. And once we achieved vendor consolidation, the next step was to go ahead and cluster these and identify the top tiered vendors and the bottom tiered vendors. So we used density based unsupervised learning algorithms and also distance based. And we can see from the silhouette scores, Gaussian mixture models and k-means were the winners. We went ahead and used Gaussian mixture models because the results that we got were made sense in terms of being consistent with what we had identified during our initial EDI phases. Going forward, the 2D scatter plot you can see tells us about the spend and risk trade-off across each of these 4 tiers, and we can see that the tier 1 and tier 2 comprised of only about 8% of the total vendor base, but they amounted for a humongous 92% of the total spend, and vice versa for the bottom 2 tiers, which we labeled consolidated vendors. Coming to the business impact, the solution that we built will essentially help our clients reduce and eliminate the number of duplicate services that is being provided across business units. Especially within the travel sector, we identified a plethora of vendors that were providing homogeneous services, and we identified about 128 million in opportunity costs that they could gain in terms of eliminating those bottom-hanging vendors. Similarly, in professional services, we identified a bunch of contracts that they could renegotiate and include work orders from the bottom tiers into the top 2 tiers in terms of maximizing their opportunity cost again. And also we could see that within the marketing and the IT software business units, they were pretty flushed out, and although the some opportunity that still existed could be minimized in terms of strategies such as competitive bidding. And moving on to recommendations, we identified a few strategies that could help further better the model. So one of them is consolidation at the country and a category level to help us understand the dynamics and the interaction of our clients with various business vendors. And similarly, scorecarding will help them try and understand which vendor is more strategic, and trying to also monitor the switch between tiers across time will help them strategize vendor proactively in real time, and also collecting more vendor data will help us include various dynamics into the model. Now, coming to the future scope, besides spend and risk, we also identified in terms of forecasting demand, and also in terms of renegotiating contract rates, and also tracking those off-contract spend data is something that could be included into the model that will help us capture the holistic interaction of a vendor with the business and consolidate them as we go forward in time. Thank you.